Hi everyone, welcome to Business Statistics Unit number 4. Today we're going to be talking about landmark summaries. So let's go very quickly into this. So first of all, what are the landmark summaries? So we're looking at the most typical values. So in this case, the most typical values is the value that happens the most often. So let's look at, let me get my cursor here. Most typical values that we have is the average or the mean. It's different name, but it's the same, average and the mean. Sometimes I will refer as it as a mean. We also have the median, or which is halfway point. The average of the mean is this one. When we have in quantitative data, we do the average. You know how to do averages very well, but what happens with the median? Sometimes we have normally distributed. For normally distributed, an average works very well, but what happens when we have data that is not normally distributed? In this case, it's better to use the median because it's just the half point. In this case, this side will look the same as this side. Okay, very good. And then we have the mode, which is the value that repeats the most, right? It happens the most times. As simple as that, right? So in this case, we have these three values, which are going to be very useful for us. Okay, then of course, like I said, I have the average. The average is, I don't really need to explain that much. You've been doing averages for the rest of, well, not the rest of your life, for all your life you've been doing averages. So 8 plus 8, 16, 16, two values divided by 2, the average is 8. As simple as that, nothing else, nothing more. Okay, very good. But anyways, it's a landmark summary, and you have to know that it's a landmark summary. Now we have the weighted average. The weighted average, let me explain you to you in a very simple way. Weighted average is when we have to give different importance to the items that we are analyzing. So let me see, for example, here I have, if I have things that I care the same because they are the same, 1, 2, 3. So this one, the value is 2, the value is 2, 2, and the value is 2. Okay, so these are the same. I mean, I'm gonna add them, and it's the average is 2 plus 2 plus 2 is 6 divided by 3, so the average is 2. Simple as that. But what happens when we have, for example, different values? Let's say, for example, we have one smaller one smaller one smaller one. So in this case, we're going to talk about, for example, factories. So this factory has 10,000 employees. Then in this one we have 5,000 employees, and in this one we only have 2,000 employees. So why do we use the weighted average in here? For the simple reason, what happens if I, for example, I want to measure the average productivity of the factories as a whole? So I'm gonna say, if I do that, the average productivity of this one is gonna be higher than this one or than this one, just because of the size. So what I do is I will assign a certain average, and see, in this case, that will give us a more I will give us a better result. So in this case, for example, I can say, because in this one the weighted average I want to see, so I'm going to assign let's say 5. Okay, 5.5, right? The importance of it is 0.5. In this one the importance is 0.3. In this one the importance is 0.2. Okay, so let's talk about this one. In this case, we had 2, 2, 2, and 2. So the average is 2. So in this case, it's going to be different. So the average productivity for this company is 2. No, so we're going to do 2 times 5, 2 times 0.3, and 2 times 0.2. And that's going to give us the, well, we're going to add them, right? And then once we add them, we're going to have the final, well, the weighted average. So in this case, we can see it, for example, on the next slide. Let me go to the next slide. That's a better example, where we have, for example, the stocks, right? So we, like I was explaining just now, we have the rate of return, for example, but for us they have different weights. Some of them have more importance than others. So what I'm gonna do is just very simple, the rate of return multiplied by the weight plus plus plus, and this is the weighted average. Okay, we use this one when we have to give different importance to different factors. They don't place all the same equal, right? They don't have all the same importance. Very good. So now we have the median. The median is very simple. Like I said, this is just the middle. That's it, as simple as that. So in this one, we're going to have always a scale, and in whatever that scale it is, it doesn't matter that the data is like not skewed or is evenly, what is exactly in the middle. Okay, so what is exactly in the middle? You realize here this is longer, but here it's thicker. So that one is just the middle value, as simple as that. Okay. Now, there is some special cases where we have to calculate the median in a different way. For example, when it's an odd number, let's say, for example, 1, 2, and 3. Okay, so what is the middle value? 2. This is exactly in the middle. Okay, there's one number to the right and one number to the left. That's it. And then if it's an even number, when we have, for example, 1, 2, 3, and 4. Okay, if it's not quantitative, if the data is not quantitative, I have to say these numbers are 2 and 3 are the median. When it's quantitative, what I have to do is 2 plus 3 equals 5 divided by 2 equals 2.5. Okay, so that it is. So in this case, like I said, this is the special cases where we need to consider how we're going to calculate the median. Very good. So let's continue. Now the median, the mode, as I mentioned, the mode is the most category. So for example, if I have here red, blue, 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 red. So what is the mode? Blue, because it was the value that was repeated the most times. Okay, simple as that, very simple. So now let's look at it in the example. So in this example, for example, we have a factory. There's some problems in there, and we have to know what's the mode, or what is the problem that we need to carry the most. So in this case, for example, we have solder joint has 37 times, plastic case happened 86 times, that quality problem. Power supply had 194, dirt has 8, and impact was 1. So in this case, what's the mode? The mode is the power supply. So in this case, that statistic, the mode, what repeated the most is what I have to fix as quickly as I can. And that's how we use the mode in a practical method. Okay, very good. So which summary would you use? Well, we can say very simple that whenever we have qualitative data, we will use mostly the mode, right? The mode, or the median. Also, we can use, no, the median, we're not use it. Sorry, the mode. And then when we have quantitative is another case. In quantitative, we can say, so for example, in quantitative, the average, we can use it. The median, we can use it. The mode, we can use it. When it's ordinal, we cannot. When it's nominal, we cannot, and we cannot. Okay, why? Because again, that's not possible. So anyway, so this one, I want you to look at the following rules in here, because also we have to look at whether the data is normally distributed or not. Okay, this one, if you don't get when to use this summaries, don't worry about it. We're going to be doing the practice, and in the practice you will understand very quickly what we're going through. Okay, so very good. Now, there's, like I said, whenever we have quantitative data, we usually are going to be dealing with quantitative data for this course. You don't have to worry that much about qualitative, because qualitative is very difficult to to um to compute, and that involves too many things. So for this semester, mostly we're going to be doing qualitative data. So now in this case, when we have a normal distribution, you can see that the average, the median, and the mode are going to be located all in the same place. All in the same place. The problem is when we have skew distributions. In skew distributions, they are not going to reflect the same, because like I said, there might be some data that is skewing. So in this case, the average gets messed up. Okay, so in this case, the mode, yes, the mode is going to be the peak always. Okay, but it's not going to match the median, and it's not going to match the average. The average, again, is exactly middle point. Means on the left side, there's the same amount of data that on the right side. Like, but this one goes all the way to the top, this one goes all the way to the right. And simple as that. Okay, very good. So now, let's continue. Percentiles. Percentiles is very simple. In this case, we're just going to be looking at in 100%. 0 to 100%. Let me put my pointer. From 0 to 100%, where the data is located. And we have, of course, the extremes, the quartiles, and the box plot. We're going to use them. It's just very simple. We're going to be looking at lowest value, highest value, 50%, lower quartile 25, higher quartile 75. Okay, lowest, maximum. Okay, so we have here what we call the 5 landmark summary. What was 1, 2, 3, 4, and 5. The lowest, the highest, 50%, 70, 25 lowest, and 75 highest. And as simple as that. So we use these quartiles to see where the data is located. Most of the data maybe should be around the 50 percentile, because that means it's a normal data, and that's correct. And if it's in another quartile, that means that perhaps the data is skewed, and that doesn't work. Okay. So that leads us to the 5-number summary. 5-number summary precisely is what I was mentioning just now. So in this case, we're going to look at the box plot. Let me go through the box plot. Box plot is just a graphical representation of the 5-number summary. So in this, the 5-number summary, when you look at it, we have here the largest data value, lowest data value. We have the median. In this case, you realize the average and the median, they are not the same, so it's slightly skewed, not too much, right? Because in this case, for example, I can say that the median probably is around 16, so it's not too far away. It's not a big problem. Small skewness doesn't cause much issues. Big skewness is where we have to do something. So anyways, in this case, we have lowest data value, highest data value. I mean, even if in this one the highest value is 25, we never got it. So the largest data value in this data set was 20. Okay, then low per quartile. In majority of the data is within this square. Okay, this largest value is rare because only one person reached it. This 9 is rare because only 1 or 2 or 4 reached it. But that's it. And then we have outliers. You realize outliers are a dot. The dots can be here or can be here. Usually can be here, right? We're gonna see them. Here the outlier was 0. Someone got 0. So in this case, the outlier appears at the very bottom. But like I said, it can be, for example, at 3. Then that's fine. Okay, very good. So that's a box plot. Like I said, most important of the box plot is that we very quickly we can see, okay, Zoom, they give you the information, and you can say majority of the data is between 13 and 18, and that's it. And sometimes the largest one is 20 and the lowest one is 9. We have an average of 15.3. So say, for example, I had an exam. quickly tell me how the students did. I can tell you that most of them did between 13 and 18. So I'm happy with that. There's some smart ones with 20. There's some ones that didn't study that hard with a 9 1. Okay, very good. So that's a box plot. And then we have the cumulative distribution. Cumulative distribution, I'm just gonna go graphic. In this case, it just keeps on adding the numbers, right? So for example, in this case, what we do is to see how there's an increase on a certain number. So we keep on adding the numbers. So in this case, we have one value and then we add on the next one and the next one to see how it's increasing over time. This is, for example, what we do with the coronavirus right now. The coronavirus right now doesn't say like, oh, we have 3 cases today, 4 cases today, 6 cases today, 7 cases today. What they start to do is, okay, we have, let's say for example here, we have 3 cases today, and then they don't say 4 cases today, and then they don't say 6 cases today, and they don't say 7 cases today. No, that doesn't work because it's not cumulative. What they do instead is they say, okay, we have 3 cases today, plus 4 cases today, plus 6 cases today, plus 7 cases today. So you realize here exponentially starts to grow. Okay, as compared to this one that is just comparing day by day. So that is important when we do a cumulative distribution. A cumulative distribution, we always use to see how things are increasing over a period of time. And I think that's all for today. Thanks again for watching. Don't forget the assignment in this one. We're gonna be doing 5 landmark summaries with Excel, so make sure you watch all the instructions, you follow, and then I'll give you some practices that you can practice on your own as well. It's important that you understand all these concepts because we're gonna do them on the assignments on Excel, and if you don't understand them, you cannot apply them. Thank you so much, and I'll talk to you soon.